In this video, we're going to talk about two force members. So we're going to take an object like a rod or something, or it could be any body, but the main criteria is that it only has two forces acting upon the object. And there's only one specific way how you could draw forces about these objects, or these two force members. So I'm going to draw it incorrectly to show you what's wrong with this orientation. So let's say this is a two force member and it must be in equilibrium. Since we're in a statics course, it must be in equilibrium. So let me draw the forces going this way. So this is the force going that way, as another force going that way. And as we learned before, these are same in magnitude but in opposite direction. What happens here is that we actually create a moment. We create a moment about the center of mass. However, if we sum the forces in the x direction, what we get is that it just equals 0. So although this, by just looking at the forces, there's no net resultant force, there is still this active movement which is caused by this couple. So what actually occurs for this to be in equilibrium and to be a two force member, what happens is that we need to apply the forces in the direction that is opposite in direction but equal in magnitude. So what we could do here is actually define the forces going along this axis of the rod. So we can define F going that way and define F going that way. So whenever you have two force members, the force acts along the direction of this rod. And as you can see, if you call that the center of mass, there is no moment acting upon the rod because there's no perpendicular distance from the force to the axis of rotation. But you can also have more weird looking rigid bodies that have weird shapes. So we could say we have some rigid body that looks like this, something really weird, and we can define it like that. If I could draw this somewhat correctly without touching. So let's say you have some weird part that has like that, and it's being pinned down at these 2 points. So for this to be an two force member, there has to be a force being applied here and here. So what we can do, I'm going to save some time. So the forces must act in this direction for it to be in equilibrium. So they must act in that direction for it to be in equilibrium. And that's simply because we don't want any moments acting upon the object, and we don't want there to be a force that offsets this free body diagram. So a major application that we're going to use this for is that basically two force members transfer a force through a body to another body. So this is probably going a little ahead, but we could define a two force member going in this direction, and let's say we created, it's connected to this part and this part. So if the net force acting upon this object points in this direction along the rod, so this is the force of the rod, this would be pointing in this direction by Newton's third law, I believe, and this is going to be pointing in that direction, and this is going to be pointing in this direction. So basically, there's this two force member doesn't have any moment acting upon it, and these forces are equal in magnitude but in an opposite direction. So this is a valid two force diagram, and basically the force being applied on this object or this part of the machine is being transferred to this part of the machine. So that's what a very useful idea and concept that we can use later to solve problems.